Okay, so in this video we're going to take the final step and actually allow our Textworld to support multiple players. So before we think about any of the kind of network part of this, let's make the changes that we need within level so that it can support multiple players, because as you notice, right now inside my level I have a single field for a single player. So I think the first step is going to involve adding a data structure that will let us have as many players as we want, and then making sure that we can add them and remove them, and that we no longer have references to a single player. So let's start this way. Let's start by deleting the player. And ideally, if we've designed this right, that should only actually break in one place. It looks like maybe I didn't design this totally perfectly. The reason it should only be a problem in one place is because the getter method is what should be returning the player instance. We shouldn't be referring to the instance variable everywhere. And actually, maybe that's okay. So what's this other one up here? Oh, set player. Okay, great. So we did design this okay. So for the moment, I'm going to delete set player, and that's going to turn into like add player. Or actually, let's go ahead and do this. So let's create an array list of all the players called players, and then players equals new array list, and then we'll need ways of like adding new players or removing the players. Before I had this set new player method, which prompted the user for a name and a description and created the player object and so forth. So let's delete that entirely and just have add player, and we'll say players and it's an interesting question. Let's add a to-do. So like notify world, so like do something else. And then let's have, well, let's think about this. Let's maybe enforce unique player names. So I'll have add player be Boolean, return Boolean for whether or not the player was successfully added. And we'll say if p dot, if it's not the case that that our level contains a player with the player's proposed name, then we'll go ahead and add the player. Otherwise, we'll return false. I mean, maybe it's a little controversial to enforce that players have to have unique names. An alternative would be players have unique ID numbers, and then you could have overlapping names. I don't know. I kind of like the idea that everybody has to come up with their own handle, if you will. So let's make this. So if p.getName equals name, and let's make it case insensitive. Okay, so we're looping over all the players and checking if any of the names are equal to the proposed name, and if one of them is, we'll return true because we already have a player of the name. Otherwise, we'll return false. So now if it's not true that we contain the name, then we'll add the player. Okay, great. So now let's make remove player, and we'll have two versions. We'll remove the player by name, and now that names are unique, we don't have to worry about what if this matches multiple players. Yeah, I guess let's do Sure, let's do this. So again, we're looping over all the players. and oops, if p.getName equals ignore case name, then we'll return players.remove p. Oh, wait, what am I trying to do? Oh yeah, this returns Boolean. Okay, great. So, all right. So, and then we'll return p. Does that make sense? Yes. Okay. So otherwise, we'll return null, as there was no player to remove. Okay. So now we've got a way of storing lots of players. We can add players. We can remove players. Let's add another to-do here. Generally speaking, we probably don't want these methods to announce these things to the world for the same reason that you don't want to put print statements inside methods that are for altering your variables. Because maybe you have occasion to just add and remove players without letting people know, and you can let people know separately. By putting print statements or other kind of announcements here inside the method, that's really limiting the flexibility of when you can use those methods. Okay, but let's continue the refactor. So we've broken a number of things here, right? Get player. So let's delete get player because we no longer want that. And that's created a whole host of other problems because the way that we'd written this code, we use get player all the time everywhere because we'd kind of assumed this single player model. So here I've got this add popstar. And remember, when popstars get created, the popstar is following a player object. So I was getting the one and only player object. Now we're not doing that anymore. So because I'm not thinking about gameplay right now. Really, I just want to be able to test. So instead of get player, I'm gonna create a method called get random player, which will return a random player from the list. So let's. So we'll say if players.size equals 0, then we'll return null. Otherwise, return players.get, and then we'll players.size. Cool. Otherwise, we'll get a random player. Okay, and in just a second we'll have to make sure that popstars. Let's do this for Wumpus also, but we'll have to make sure that popstars and Wumpi are able to deal with possibly not having a player. Like they have to handle that null case gracefully. So yeah, let's do that. Well, let's do these first, and then we'll come back to that. So init items. So right now, why were we doing this? Oh, we were just getting. So I wanted, when I make a lobster, I wanted it to be placed in the room where the player starts. But actually, I don't care about that anymore. So I'm just gonna have the lobster get placed in a random room. So get random room. Great. And now let's do that same thing down here. Why do we need that? We don't need that. Okay, fine. Okay, and now what's this down here? Oh, and then this is its own whole other thing. Okay, so let's fix popstars and Wumpi. Okay, so the issue with Wumpus and popstar was that when they get created, we assign them a random player, but because we're creating the Wumpuses at the very start of the game, probably before any players have logged in, the Wumpuses are going to get assigned null when they get created for the player. So we need them to be able to handle the situation where there is no player. What happens now? So what happens now is we run choose next room, which runs find safe room to move, and where are we actually using the player? Is safe. Okay, so right now this would just throw a null pointer because we're not checking to see if p is null. So I think here's what we should do. We should have the Wumpus maybe move randomly. So like if there's no player, let's ask the level to give us a player. And if there's still no player, then we'll move randomly. That seems like a good policy. But let's remember how all of this works. So my Wumpus extends autonomous creature. And in autonomous creature, we've got, I'm overriding the abstract methods act and move. Act is empty because it's whatever action happens after the movement, and right now, like, nobody does anything. Move runs a choose next room, and then as long as the next room exists, we move there. So that's what's actually happening inside Wumpus is, Wumpus is the way a Wumpus chooses a next room is by finding a safe one that isn't leading toward the player. And so then all the rest of this code is about checking the neighboring rooms to see if they're safe. So I think what we want to do is we want to override that parent move behavior. Is that what it's called? Or is it autonomous creature? Yeah, it's just called, okay, great. So in pseudocode, what I want to do is like, so if no player, well, I probably don't even really need pseudocode. So if P is null, then P equals level dot, do I not have a level? How do I not have a level? Let's investigate this. So autonomous creature extend doesn't have a level, extends creature. Oh, so it's only got a room, not a level. Okay. But do players have a level? Let's look for player. No, players don't either. Interesting. Okay. Well, yeah, so let's do that. I want all these creatures to have a level object to be able to do stuff with. So let's go back to creature. Great. Private level. And then let's put that in the constructor. Oops. Alright, so now, so now autonomous creature, same thing. And so now chicken will be the same thing. And Popstar. And Wumpus. Oops. Did I? No. Okay. All right, great. So that's all of those ones. And now where we actually create all of those creatures in the level init methods, we've got to provide a level object. So here we are back in level. And so we should pass in this because we ourselves are the level. And then let's pass in this. And let's pass in this. Okay, great. And then who are you down here? Oh, we're still dealing with this problem. Okay. So where were we? We were here in Wumpus. Great. All right, so now that we've got a level, did I make it private? Sorry, let's make it protected. I think protected, but it seems okay. All right, so now I can say level.get. Why can I not? Is get random player private inside level? I bet it is. get random room, get random player, yeah. So let's make this public. Okay, great. So, yes, so where were we? So if there is no player defined, then we'll ask the level to give us a random player. And if there is a player, we'll get one. And if there's not, that will still be null. So now we'll say if p equals null, then we'll move randomly. Otherwise, we'll run super.move. And super.move okay, so otherwise, do I have a move to neighboring room? So I could move to a random neighboring room. Let's do that. Okay, great. And that's very much the same structure that I want to have happen inside Popstar as well. So here in Popstar, let's override move. And we'll say if we don't have a player object, let's get a random one. And if the player is still null, then we'll move randomly. Otherwise, we'll do our normal moving that we inherited from the parent, which runs our own choose next room to cover the logic of how we choose our next room. All right, cool. So I think that problem is now out of the way. Whew, that was a long time. So one more thing to fix. Maybe one more thing to fix. Where were we? Level. Yes, so we were in the process of getting rid of references to get player since there is no longer a single player. So this was something I brought up in the last video that was ugly. We're currently inside the room class, which is the inner class of level. And display full description is what we were using as the sort of generic prompt for a user. So we get the player and we describe the room that they're in and the items they have and all this. Like this method is not really anything to do with the room that runs the method. So that's a good indication that all of this code should be going somewhere else. And I think where it should be going is most likely in a command. So I'm going to go ahead and delete this entirely because it shouldn't go here. And let's put it inside the look command, I believe. Yeah. So the look command is who was running this before. Why does it still think this is a thing? Yeah, cannot find declaration. Great. So what we want to do is something like this. We want to get the player, and this is yet a further problem that we're going to have to face. Like all of these commands are getting a player, and we have to figure out like which player is running the command. So we'll think about that in a second. But assuming that kind of makes sense, we're going to get the player's room and get the name, and then all this stuff. So get item string comes from where? That was also in room. Oh, so that must be the items that are in the room. So let's do this. So level.room, current room equals p.getRoom. Oops, yeah. And so now we can say current room, and then like this, and then like this, and then like this. And then parser, I thought we... Oh, do we not have access to the parser here? So this is where we're displaying all the valid command words. I don't know. I don't see why this is not static in parser. Let's go to parser. Get command words display string. Yes, that seems fine. Oh, I see why it's not static. It's because commands. Oh, but that's all right. All right. No, that's fine. That should work out. So going back. All right, and so now we just have this other issue to deal with. So I think we'd fixed all of the things inside level. Is that accurate? Yes. Okay. Okay, so let's tackle the rest of the references to getPlayer, which we can do all in one go. So let's look at where they are. So here in ClientHandler, we're asking the level to get the player, and the ClientHandler needs that because the player objects are now how we do the print statements. We give the player each. Oh wait, where are we? Sorry, ClientHandler. Here we are. So each ClientHandler has a player object, and we get the player object from the level because now all of the printing happens through player objects because we set the print writer for a particular player to be the print writer from this ClientHandler, and then whenever we want to display something to a client, we tell that player to print line. So the solution here is not to get the player from the level. Instead, each client handler needs to create a player object and then tell the level, hey, here's a new player joining your game, and I am the handler for that player. So let's look at where these other things happen, and then we'll come back to the solution. So the other problems are inside specific commands, and inside each command execute, we get the player because that player is who we're going to print the outcome for. Like that player is who's executing the object, and so that player is the one that needs to see the print statements. So same thing, sort of the same thing. So a client handler was going to, rather than ask the level for a player, was going to actually create a new player object. Similarly, we're not going to create new player objects, obviously, inside commands, but each command needs to know which player object was running the command. So all of my commands extend abstract command. So just like abstract command has a level, abstract command is going to need also a player, which is who's running the command. And parser is the right class to fill in that information. So inside parser, when we, not in init commands, where are we? When we parse the command, the client handler runs parse command, so the client handler knows which player is trying to do this command. So the client handler should give the right player object to parse command here, and then parse command can set the resulting command up so that each command object knows which player it needs to send the results to. So that's the general kind of solution we're looking at. So first things first, let's go to the client handler. So here, instead of getting the player, we need to construct our new player object. So a player requires a name and a description. So here's what's a little bit awkward. Ideally, so we need our names to be unique names, right? Ideally, you would have the client actually type the name they want, and if that name is already in use, you would say, hey, already in use, please type in a different name, and you'd kind of go back and forth. We may or may not do that in a second, but I think a sort of a more straightforward thing to do is going to just be assign each new client a new randomly generated name. Just say, hey, you are now Turbo the Bold. So all that stuff that we deleted last time with the silly names, maybe it's time to put that back in. So when I construct a new player, let's actually ask the level. Do we have a level yet? Yeah. So we'll ask the level to get random name and get random description. Actually, let's do this. What else does a player expect? Okay. So I'm going to overload the constructor. So we have, but we don't have a level in here. Oh, we do have a level in here. Great. So get random name, get random unique name, and description. Okay. Oh, we don't have level. Oh, because we haven't. What's happening here? That's an interesting oversight. So when I refactored creature, I never actually changed player. So player takes a level as input here. And then, so we'd still need to do this, I guess. All right, fair enough. So now let's have the level provide the unique things. Here, I'm gonna do this really fast and then show you the result. Okay, so let's see what we did. So here we are back in Client Handler. As discussed, the client handler in the constructor creates a new player with this overloaded constructor where we just give the player the level. And then the constructor asks the level for a random unique name to be sure that it's okay to create a player with that name. And then for a random description. The way the random unique name works is so at the top here, at the top here I have some random first names and some random last names. Well, not really last names. The same thing we had before. So like Philo, the straightforward. And then where were we? So that was so we keep constructing random combinations of a first name and a last name as long as the game doesn't already contain a player with that name. And like in theory, we'd run out of names here, and so I have a counter. And eventually, if the count is larger than the number of unique names we could construct in that way, then I just add a digit at the end. And that still has a maximum, but I'm not really worried about that right now. The random description is not so random. It just says in elf. And of course, you could think about how to make that better if you wanted to. For the moment, though, let's go all the way back to Client Handler. So now the Client Handler, we've constructed the player, and we set the player's print writer to be this one. And now, what's happening? What are we trying to do here? So before, the first thing that we did was we got the full prompt. Now that no longer exists because we kind of put all of this code inside the look command. So I think the first thing we want to do is actually run the look command. But before we can do that, we have to take care of the other half of this, which was make sure that commands actually take a player as input so that they know which print writer to use when they're executing. So let's do the other half of that now. Let's start inside abstract command. So I said just like it's got a level protected, it should have a player. And the right place to set the player is in the parser. So here where we're let's actually go back to the client handler. So here in the client handler, we're saying parser.parse command, and then we're giving a request. And that request is whatever the user typed. Let's also give the current player object that's associated with this client handler as an input. So let's add that as a second parameter. Great. I think great. What's happening? Okay. So then once we've looked up the command, now we want to say C. Maybe we should make it as part of init. Should we, or should that be separate? Let's make it separate. Player. So what that means is that we've got to create that method in command. And for me, command is an interface, which means now that it's part of the interface, abstract command needs to implement that part of the interface. But why is it not complaining? Hello? Oh, because that's player. Sorry, abstract command. Well, I don't know why abstract command isn't telling me that I'm not implementing command. It should be. well, let's do this. So public void set player. So this dot player equals player. Great. I'm a little bit upset about this. Well, I guess that's okay. All right, so where were we? Right, the parser. Okay, so now inside the parser, we look up the command that's the one that they're looking for. We set the player as the current player. We initialize it with the thing and we return it. And so now the only thing that needs to happen is inside each of the individual commands, instead of getting the player this way, we can just say, oops, we can just replace P with player. Technically, maybe it would be better form to have a getter method. And now when we print line, like who we're actually printing to is the player associated with this command. What is happening? Oh. Great. Okay, so I'm going to go through and make all the changes, and I'll let you know when anything weird happens. Okay, so all that's been taken care of. So let's sort of review what's going to happen to figure out where are we missing parts. So we're back in ClientHandler. In the ClientHandler, we create the new player object, we set the print writer. Oh yeah, the other thing that we have to do is actually actually add that player to the level. Great. And now let's run the look command. So let's so command look equals parser dot parse command look, and then let's say look dot execute. And what that's going to do is that's going to, what's the problem here? Oh yeah. And that will actually output the thing that we wanted to output over the socket back to the user, so that way they start off with the appropriate looking prompt. All right, everything else in here looks good. We don't have a clean way of having players exit the game right now, because if a connection gets dropped or something, the player object is still there inside the game. But let's go ahead and test what we have right now before turning to that issue. Okay, so running the server. Oops. Okay, well, I guess we didn't fully finish cleaning this up. So let's see what's happening. All right, so we no longer need to do this. Oh, this is all in main. So we're not even running main anymore, but I guess let's... Yeah, all right. Let's think about what main is going to do. Or actually, I guess, since main is sort of obsolete now, should I just delete all of main? Pretty bold. Yeah, I'm going to delete all of main. Nope, false. I'm going to comment out all of main. All right. Was anything else broken here in server? Okay, yeah. So, oh yeah. All right. So, in server, remember we were initializing the level, and one of the things that we did was set the new player, but we won't do that anymore because now that's happening once a client connection is made. All right, I think everything else... Okay, so let's try this again. We'll run the server. Oh, that is not it. Oh, I forgot about the empty command. All right, well, clearly I didn't do a very thorough job here. All right, so as before, the server is waiting for the client connection, and animals are moving around. And that'll be another thing for us to fix in a second. That's the old client from before. So let's run client. So one thing I'm noticing is the client did not actually display what we were expecting, but let's look. Okay, so the client is not receiving what we're expecting. And the question is why? So, oh, there we go. Oh, there we don't go. Yeah, okay, whatever. All right, well let's look at the look command and try and figure out why it's not working. Oh, so you know what I'm thinking? Current room. Where does a player get its room from? Ah, not in the constructor. It extends creature. Yeah, I bet there's a setter method for rooms. Not in creature. Oops. Move to neighboring room. Get room. Is there no set room? Oh, set current room. That's kind of bad naming. Okay. Cool. So I bet that's what happened. I bet that when we created our players, we didn't give them a room, and so maybe there's a null pointer happening on the thread that's not, like, that's not visible to us. So let's go back to where we're creating the player. Where is that? Client handler. So before we add it to the level, player dot set current room, level dot I'm going to make a method called get starting room. We could create players in random rooms also, or like give them a choice or whatever. What did I call it? I created a root node name. Yeah, so root node name. Okay, so root node name. Whoops, root node name is the name of the first room that I guarantee exists whenever we create a level. So that way, even if only one room exists, we're sure that it's this one. So we can get the room associated with that name and return it as the starting room for the players. So let's go backwards now. So actually, maybe it's a little bit goofy to have to run that ourselves, so why not? Let's actually have that happen in the player constructor, because I think that's a little bit nicer. So set current room to level dot get starting room. We'll do that down here also. All right, and so now that we've done that, we actually don't need to do it here. It will already be done. All right, so let's try this one more time. Actually, I'm going to stop it and run it again, and I'll tell you if anything interesting happens. Okay, I know where the problem is. So I think that we are not seeing anything because, oh, sorry. So where I stopped it last, I was running it again. The same thing happened. So I'd type look and nothing would happen. And what was happening is on the server side, we'd created the, well, here, let's go here. So client handler. So we'd made the connection with the client. We ran the client handler constructor. We were doing these things, and we got as far as constructing the player, and here it was stopped. And by stopped, I mean stuck in an infinite loop. And so if you think about where is the only place a loop happens, it was here in get unique random name. And I know exactly what the issue is. So I'm going to continually do something as long as our game does not contain the name we generated. I mean the opposite. I mean keep generating names as long as the names we generate are already in the game, because that's the situation when we want a new one. If it's not in the game, that's perfect. We want to stop looping because we know that that's an okay one to add to the game. So even though I haven't so even though I haven't really tested it, I'm really pretty positive that's the problem. Yeah, cool. Let's do it. So running the server, there we go. Running the client, there we go. So now we see you are currently in the hall, blah, 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 blah. I don't like how it displays this before my caret. We should fix this. But anyway, so I can type look, I can type take Oh, the lobster's no longer here because it got created in a random room, so let's go look for it. So let's go bedroom, move to the bedroom. Now I can look, and it says I'm in the bedroom. Let's go to the dungeon. Let's look. There's the lobster. Take lobster. You've taken the lobster. Great, no more lobsters. All right, cool. So that seems to be working. The real question is, can we do it with another client? So let's run client again. Is that going to run another client? Yeah, great. So let's look. I wonder if it's going to say, here, let's go bedroom. And let's go dungeon. Look. Interesting. Okay. Well, anyway, so I seem to be able to do things with multiple clients, and that's good. There's still a downside, though, which is it would be nice if what's currently happening in the server, like all of this things moving around, if something like that were happening for each client. So, for example, when this player entered the dungeon and the first player was already in the dungeon, it would be nice if it said, like, so-and-so has entered. And then if they leave, it says so-and-so has left. It would also be nice to provide a way of players to, like, talk to each other. And it turns out the solution to both of those problems, I think, will be the same. And I think it's going to be a version of what's called the observer pattern. So let's do that in the next video.